Get recording? It is. So welcome to week 6 of Math 20. We're doing mad science, measurement, and then polygons and circles, the last parts of mad science. So we start with definitions because whenever we have a new topic, we need definitions. And so the first two are perimeter and area. Perimeter is the distance around the edges of a shape. I like to imagine there's an ant starting at one corner and then walking around the outside of the shape. Remember that perimeter is a length. You're going to have an answer that's labeled something like inches or feet or meters or centimeters or miles, right? Then the other definition is area. So the area of a shape is how much room the surface takes up if you paint it. Imagine that you have to paint your floor. Then how much area do you have to paint? How much paint do you use up? Area is not a length. It's an area. So it's going to have a different thing other than just like feet or inches. We'll talk about that in a moment. The third definition is polygons. Polygons are closed shapes whose edges are straight lines. And you know a bunch of them already. So rectangles, triangles, parallelograms, trapezoids. If you don't know which ones are which, we'll talk about that very soon a lot, so that's okay. So to start with, then look at the bottom 93 and 94. On your own, try to draw a polygon with 7 edges and try to draw a shape with 4 edges that's not a polygon. Okay, everyone try this?
Yep.
Okay, for 7 edges polygons, then we could share ours if we wanted, but anything that has 7 lines and eventually comes back to where you started. So for 93, yours can look totally different. 1, 2, 3, 4, 5, 6, and then get back to where we started, something like that. For 94, there's 2 ways to do this. Polygons have to be closed. So maybe you made something that had 4 edges and wasn't closed. Closed means comes back to where it started. And polygons have to have straight lines. So maybe you made something that had a curve instead. Or you could do both. Have a curve and it doesn't come back to where it started. Okay, everyone happy with those 2?
Yep.
Okay, perimeter going around the shape is not much to talk about because you can all add up numbers. My warning for perimeter is to mark a corner. It doesn't matter which one, but when you're starting with perimeter, mark a corner. Because otherwise there will be someone that when they're taking a test either double counts a number or finishes early and doesn't realize they neglected something. Just because of how our brains tend to turn off on math tests. But other than that, you're just adding up the numbers. You can do it by hand, you can do it with a calculator. Adding up a bunch of numbers isn't hard at all. We also said that for perimeter, the answer is a length. So it's going to have something like inches, feet, feet, meters, something like that as a label. And I'm not really sure what else to say about perimeter because you know how to add up numbers. So just to make sure decimals don't scare you, what are the perimeter of these two shapes?
$12 on the top.
Yeah. So pick one corner, maybe up here. 5 and 4 is 9, 10, 11, 12, and he remembered to say inches. So great.
18.2 for the bottom, right?
Let's see. We have two 6.1s. Everyone see how the bottom is the same as the top? And we have two 3s because the left and right side are the same. So two 6.1s gives me 12.2. And then 3 and 3 more than that. So 6 more than that, 18.2. Yep. And I should say inches because it says inches.
Yeah, sorry, I should have gone with that as well.
You want me to write that down on the slides?
Here.
Sure. Oh, okay. Oops. So I'll take a corner and say I'm going this way. 5 plus 4 plus 3 is 12 inches. And then on the other one, and this is also 6.1. And this is also 3 inches. So I'll pick a corner and go around. Point 1 and point 1 makes 0.2. 9 and 9 is 18. And it's still inches. Questions about either of those?
No.
Okay, so how could it possibly be tricky? So one way is to make it not really a perimeter problem.
I have a quick question, Dave.
Sure.
In Math 20, are we going to ever switch out where, let's say your bottom example right there is 6.1 inches on the top, and then instead of 3 inches, would it ever be 7.62 centimeters? Are we going to switch things up like that?
You're just, here we are. So the first way to be tricky, as he mentioned, is to say, when I'm trying to label this, I'll say, oh, wait, that's a long thing, 2.5 feet, and that's not quite as long, that's 20 inches. They don't match. I can't add things up if they don't match. That's apples and oranges. So I have to change one of them to match the other. And I don't get to pick. It says, what is the perimeter in inches? So that means that I need to have an answer in inches. So let's take this feet and get rid of it. How many inches is 2.5 feet?
30?
So yeah, each foot is 12 inches. So we'd have 12 inches plus 12 inches plus, and half a foot is 6 inches. Or you could think about it as 12 inches times 2.5. However you do it, it's 30 inches. Everyone okay with changing the feet to the inches?
Yeah.
Yes.
So now we are back to this situation. Everything is in the same measurement unit. It's the measurement unit we were asked to use. So I can finish labeling things. So I'll pick a corner, go around 30, 20, 30, 20. And run. So the tricky part here had nothing to do with perimeter. It was just that they wanted you to change one unit into the other before you started. The perimeter part was exactly the same boringness of adding up numbers. Any questions about 96? Okay, then this one's a joke. My grandfather turned 70. He started to walk 3 miles each morning. Now he's 75 and we have no idea where he is. But here's the actual problem.
That's funny.
I hope it's not too annoying when I make things wide and narrow.
That joke just clicked, and I just wanted to tell you that's funny.
Okay, so this is the other way to make these tricky. We're missing some things. We don't know. See, now this one we do. We're told all the different things, but no, I guess it's later. Anyway, so later on we'll say, what happens if you don't know this one and you have to subtract and say this side is 3/4, this side is half. I'm sorry, this side is 1/4, so what's missing must be a half, and so on. So we could leave one missing, but we're not going to do that yet. So I'm not sure why that problem is there. So that was perimeter. Area is the next thing to talk about. And I want to talk about area equals length times width for a rectangle. I'm assuming you've all heard that before, but it's actually incredibly important. So let's talk about it. So if I have this rectangle, maybe I'm tiling my floor in the bathroom or something, and it's 4 feet and 2 feet, then I can make these little squares that are each 1 foot square. One times one is one. So this shaded area here is very convenient. This is like what kind of tile I would buy at the store. And 1 times 1 is 1. So we're going to call this 1 square foot. If you're fancy, you might write it as 1 square foot that way. Or you might abbreviate the word square and say something like that. But that's describing one piece of tile. So the whole area is going to be 1, 2, 3, 4, 5, 6, 7, 8 of these. And philosophically, we've just done a whole lot because we didn't have a way to measure area before this problem. It wasn't a length like inches or feet or meters, right? It's not some distance that an ant is walking. We needed something else to say how much paint or how many tiles fill up a shape. So our answer philosophically was to pretend that the basic unit of area is 1 tile and then count how many tiles it takes to fill up the square or the rectangle. Everyone with me so far?
Yes.
Yes, okay. So again, thinking philosophically, we are now stuck on rectangles. If you give me any other shape where I can't make nice tiles fit into it, then I'm not sure how to measure the area. So that's our goal, is to generalize from this picture to more interesting shapes. We know that we can. I can physically take paint and paint a triangle, but that's a different step from what we've done of just counting tiles. So let's start by talking about triangles, and I'm going to turn off my screen share so you can see me folding paper. And I need to move that over a little. Okay, you don't get to see my top of my head as much because I wanted lots of room for this. So when you have, is this big enough? Do I need to hold it up like over here somewhere?
I can see it when it's down low.
You can see it was down low? Okay. So take your piece of paper, and your job is to take a rectangle and make it into this kind of triangle. And then tell me how much of the rectangle that we have in our hands does the triangle use. And this is, in a normal class when you're all sitting in front of me, like the hardest part of the term. There are students that are very worried there will be origami on the final exam. There is not. So if you can fold this with me, then great. And if you can't, just do your best. I'm sorry I can't come visit your desk and help you with the folding. But I'm going to put this down in front of me and take 2 opposite corners and fold it while I'm kind of pinching those 2 corners to make a diagonal line so that my paper now has 2 triangles, just like the picture on my screen. So how much of my original rectangle is each of these triangles?
Half.
50%.
Yeah, it's half of it. Everyone see that, either on your paper or on my screen?
Yes.
Okay, so now I go back and share screen, and I can write on the answer. So we had a length, whoops, make it a pen. And we had a width for our original rectangle. And the triangle takes up half of that. So I like subscripts. You can write this some other way, but area of a triangle is half of length times width. And what you've probably seen is that the area of a triangle is 1/2 times base times height. And I have no idea who started the idea that when we have a triangle, we should call this one the base and this one the height, even though we already had length and width, and those were perfectly good words. So if you have seen this formula, this is all it means, that when I have a triangle, it's half of the rectangle that contains it. If you are using a calculator, you might like the version that goes the area of a triangle is base times height divided by 2, because it's easier to do divided by 2 instead of times a fraction. Everyone okay with that?
Yep.
Okay, holler if I'm going too fast. So this one you can click and see what's happening there. Now, you might say, wait a minute, you're pulling my leg. Oops. That was a kind of artificially easy triangle because it lined up on the paper so nicely. So let's try it with a trickier triangle. So this triangle is again contained in a rectangle, but it doesn't meet at the top corner. Instead, there's sort of some arbitrary place here. It's still true that our triangle is in a rectangle. The rectangle would have, whoops, I can spell. The rectangle has some length and some width, and because it's a triangle, we're going to rename these as base and height. But now my folding is more complicated. So take your piece of paper, and if the fold that you've made before messes you up and you don't like folds crossing, then get a new piece of paper. Take some kind of random spot on the top, not nice in the middle, not one corner, just some sort of other spot along the top. And you're going to fold from there to one bottom corner. And you're going to fold from that same top spot to the other bottom corner. So now I have that triangle I've drawn on my screen. And I'm wondering how much of my original rectangle does that triangle take up? Maybe I should fold them going behind instead. Any ideas?
Nope.
Is it still half? Because it's still a triangle, but it's just in a different shape or a different position?
It is 1/2. That is true. How might we be able to prove it?
Well, we have to add up the sides on either side of the triangle.
Oh, okay, so I'll take my scissors and cut off one of them. Then what?
I don't know. I got scared when you started cutting, so I don't understand that part.
Well,
Wouldn't
you
you
wanted
just
me to add up the parts, you said, so I can't put them together unless I can physically
wouldn't
move
you
them.
just measure the triangle itself and then cut the pieces and measure those pieces and
Mhm.
not see if they're the same?
Yeah, so there's two things I can do. One is if I just put this one over here, that's enough for some people. You can see I now have two triangles that look the same. And for some people, they want more than that. They want me to get the scissors again and say, look, if I can take both these pieces, then that one goes here and that one goes here and they fit. Ta-da. So I'm going to share my screen again. So here is the thing there. We can cut out one of the wings and put it over there and we get two triangles. So if the whole rectangle makes two of the triangle must be half of the rectangle. Everyone okay with that? Either because you watched me or because you're doing it with your own paper?
Yeah, that makes sense to me.
The visual just now is what helped me get it. The paper kind of confused me.
Okay. Taking attendance while I'm thinking about it. Otherwise I forget and then I have to email everyone. Say, were you here?
So while you're taking attendance, those multiplication things that we do, like, does the number change every day? Because I've noticed it has been changing, and also
Every
too.
time you load the page.
Okay. So like yesterday I did one and I got it wrong. The day before I got it right and I sent it to you. I don't know. Are we supposed to send it to you or just do it on our own? Like, what's
Just do
the
one till
protocol?
you can finish in 3 minutes and then let me know.
Okay. Well, I did one and I sent it to you, but I'm just still going to keep practicing because I guess I'm scared for the final. And you said that was a good way to practice. So
Okay.
I don't have to send it to you though, because I did send one, correct?
Yes, you should
Okay.
have the check mark if you check the page.
Okay, perfect. Okay.
And
Thanks.
while she's asking about that, when you go to your practice tests, you'll see there's a no calculator test. On your main final, you can use a calculator. So there, if you are going into Math 60, then you need to be able to do some things without a calculator, just so that when they're done on the board, you can follow them. And so because a lot of Math 20 students go to Math 60, all of you, whether or not you're going to Math 60, have to do a no calculator test. The way the stars work, you don't have to do this if you do well on the final, but if you just get an okay score on the final, you should also do this. So you can check here, and these are the only things you need to be able to do without a calculator. So if that helps you know how much multiplication speed you need, then there you go. And this normally would have a time limit, but since it's spring term 2020, we don't. So there we go. But yeah, coming out of Math 20 with a little bit faster multiplication won't make anyone sad. Okay, back to this. So area for a triangle is 1/2 base times height, or base times height divided by 2, and now you know why. Okay, the next shape is a parallelogram. So I'm going to stop my share. We had the rectangle that we had before with the pieces, right? Don't think too hard about this. If I take one of these rectangles and move it to the other side, I get a parallelogram. How much of the original rectangle does this take up?
The whole thing.
The whole thing, right? Nothing's gone anywhere. What if I do it the other way? Whole thing, right? So what we've just seen is that it doesn't remove any area to move one little bit from one side to the other. Okay, back to the screen. So here's the hint about that, if you like it on the screen instead of in my lap. And then here is the picture of, look, I can move things back and forth and it doesn't do anything. So the area of a parallelogram is the same as the area of a rectangle. Let's talk about this a little more because it's trickier than it sounds. Someone is going to make a common mistake. On this one, I'm going to write area still base times height divided by 2, just so we have something written here. Okay, and then on this one, we have the length, which you might call a base, and we have the width, which you might call the height. So the area for a parallelogram is the base times the height, the length times the width, whatever you want to say. That means I am taking this number, whatever it's measured to be, and this number, because what I care about is the original rectangle before I moved that piece. The edges in red are a trap. If the book is very friendly, or the problem is very friendly, it won't have any numbers right here, because who cares? If the book wants to trap you, they will label those diagonals. So you will somehow try to use them in your area formula. But you don't care about that diagonal edge at all. All you care about is what this is and what that is. Bottom. Make sense?
What if they don't give us the height?
Then you can't find the area. So there's 2 reasons they might not give you the height other than they wrote a bad problem. One is they're feeling crafty. They want you to actually get out a ruler or a tape measure and measure things. That tends to happen more in elementary school than college. And the other is it's part of some bigger shape and they're missing something. You can find out this height because of other things happening in the picture.
Okay, so we don't have to solve for height.
No, that's in general you don't. They're going to give you all the measured things you care about. Okay, one more shape. So this shape is called a trapezoid. It has a base and a height that are, a base and a top that are parallel to each other. I'm going to stop my sharing. So it's part of a rectangle, right? The top and the bottom are parallel, but we've taken cuts that could be anything. There's no, they're not related to each other. They don't have to be anything. So if you are following along, take 2 pieces of paper. That's a clue about what's coming up. Stack them so that they are on top of each other. Pretend they're one paper. Take your double paper and kind of fold from the bottom corner on one side and kind of fold from the bottom corner on the other side. And then either rip or cut, because we have no idea how the sizes of these things. It's not true anymore that they're going to match up like they did with that first triangle. If I try and put together these yellow top wings, there's no reason to think they mean anything compared to what I have. So our only question then is, how can we take a trapezoid and make it into something we've already studied? If we can take a trapezoid and make it a rectangle or a triangle or a parallelogram, then we can use the tools we've just developed. And your hint is that you have 2 of them.
Would you add them?
Would I add them? Sure, tell me what to do with my hands. I mean, I could put them together this way.
No.
That doesn't make anything, I know.
Maybe put
Yeah.
the where the straight lines are, the straight edge, not the angled sides, and not the bottom side. No, like sideways.
Sideways. Like that. Or...
Can't really. No, I don't know. I can't really see your paper, so I don't really know.
Okay, the answer is I have to take one and flip it over a couple times, and then I can do that. Now I've made a parallelogram out of my trapezoid. I could do it the other way too. So back to the screen, because for a lot of you it's easier to see on the screen. So I photocopied my trapezoid, twisted it around, and then put it there. And now I have a parallelogram. Everyone okay with that?
Yeah.
Okay, so this again requires some discussion. Okay, how big is this thing? I have a top. I have a bottom. Actually, let me label them in red, because what I am labeling is only the red one's top, which goes from here to here, right? And I have a bottom, and by bottom I only mean the red bottom. It stops right there. And then I have a height. So far, so good. How far is this distance?
It's the same as the bottom in red.
Yeah, this one here is whatever we measured as the bottom of our original trapezoid. And this one here is the top. Does that make sense to everybody?
Mm-hmm.
The height hasn't changed. So I'm going to say that the area of my parallelogram, that was the overall bottom, multiplied by the height. Because we just did that. When you're finding a parallelogram, you do base times height, or length times width, whatever you want to call it. Avoid the diagonals. Everyone okay with that step? We're
No,
getting...
I didn't. I'm sorry, I didn't get it. That went.
Okay, so the bottom plus top is this distance here, because it's the bottom we had going to here, and then the top is here. And we're multiplying it by the height. But we don't want this thing that's twice as big. We just want something that was our original size with the top and the bottom and the height. So what do we do? Because we have this nice formula, but it's too big. It gives us the whole shape.
Cut it in half.
Cut it in half.
Divide by 2.
So the area of the trapezoid is going to be, see if I can fit this all in, bottom plus top times height divided by 2. And I don't like how it ran over the edge of the slide, so I'm just going to use letters. So
I don't understand why we had to go through all that work of adding another one in just to divide it by 2. Why couldn't we just like do the top plus the bottom times the height just originally with a trapezoid and just call it good there?
tell me the second part again. Why couldn't we just do
The top plus the bottom times the height just in one of them instead of 2 of them?
Yeah, I don't understand why we need to make it into a rectangle. I'm sure there's
we photocopied it so we could actually make a parallelogram.
So we just did that for fun. Like that wasn't like how to solve for a trapezoid.
Right, that was how to get the formula in the first place.
I'm so confused. Okay, let's. I'm sure it'll come clear as we
Let
go.
me write
on.
it again, just on one slide without all the busyness. So we have our top, we have our bottom, we have our height, so the area for this thing is top plus bottom times the height and divided by 2.
So did you just show us with the extra pieces so that we would understand why we have to divide by 2?
Right. Just like at the beginning of the lecture, I assume everyone knows length times width, but we wanted to talk really about why. I assume everyone knew 1/2 base times height, but now you know why. And maybe you had known base times height for a parallelogram. Now we're getting kind of iffy for average background knowledge. Almost no one arrives at Math 20 knowing the trapezoid formula. So that's what happened, is now instead of a familiar thing being, I'm learning why it works, it was like, what's happening? My brain hurts. So that's okay.
Yeah, rather than coming across just as like, this is so you understand why you do it this way, it kind of came across like you must do it this way or you will not get the right answer.
Right. Okay, as far as what you do, if you see a trapezoid and you're asked to find its area, you could use this formula. You can also, whenever you have a trapezoid, say, I don't want to memorize a new formula, and then you don't have to, because you can always say, I'm going to draw a diagonal line, whoops, and chop it up into 2 different triangles, and do 1/2 base times height for the triangles. Does that make sense? So if you don't like this formula, that's okay. You can always chop things up and make triangles, but this is a little bit more work. Since you are allowed to use notes this term, then kind of you might as well do this. The other thing to note is I can rewrite this formula I can put the top plus bottom together. I can take my bottom, take the divided by 2 and bring it to the middle, and it still works. and then times height afterwards. And this part has a name. What do you call it when you add up two things and then divide by 2?
Is it like the average?
Average. Yeah. Add them all up, divide by how many? This is the average of top and bottom. So if it helps you to remember the formula, if you wanted to remember the formula, you can remember it this way. I'm taking the average of the top and bottom and multiplying by the height. And that sort of emphasizes that the top and bottom are equal. It's not like one has more priority or importance than the other. I'm just averaging them. Another thing to note with this formula is what happens if we take our top and we shrink it. We sort of let these diagonal lines fall towards each other until they meet. Then I would have a triangle. Everyone see that? So if my top is 0, if I let those two sides collapse towards each other, then I just get bottom times height divided by 2. So it turns into the triangle formula, which should make us happy. Not that we care too much, but the fact that this formula turns into one when it's supposed to helps us sense that maybe this is actually on the right track. Okay, I don't know how much of this you'll actually need for trapezoids, but there you go. If now you hate trapezoids, that's okay. They're not that important. Can I get this all on the screen at once, or is that going to be too small? Let's do just some at a time. Oh, we'll do it this way. Okay, what's the area of my red triangle?
Base times height.
So the base, 1, 2, 3, 4. Height, 1, 2, 3.
$12.
Quietly. Okay, base times height, and then what?
Times 2.
Divided by 2. And this one isn't labeled with inches or something, but if it was, I would want to put. Okay, how about my blue one?
Wouldn't it be 9?
1, 2, 3, 4, 5, 6. Height 3 divided by 2, and it is 9. Everyone happy with those two?
Yep.
Okay, next. What was the formula for the parallelogram?
Base times height.
Base times height. One, 2, 3, 4, 5. 1, 2, 3. How about the other one?
Wait a second, isn't it 6 times 3?
No, because my actual base is only the 5.
Oh, I see.
Three times three, 9.
9, yeah. Does it look reasonable that if I took this first one and sort of straightened it up because an elephant had sat on it, that it would fill up these 15 squares? Or does it look reasonable that if I took this one that had gotten sat on and straightened it up, it would fill up those 9 squares?
Yeah.
I'm taking this little bit and I'm moving it over here to fill up the missing piece. I'm taking that little bit and I'm moving it over here to fill up that little piece. Everyone happy with these two?
Yep.
This is just 2 copies of the same one, so when I go to elementary schools, I can pass this out as actual paper and they cut it out. Okay, so area equals bottom plus top times height divided by 2. What am I adding here?
5 plus 4,
Top, not height.
1.
1. So 12. Okay, questions about any of this?
How come when I type it into my calculator, 5 plus 1 times 4 divided by 2, it gives me 7?
Um, I don't know. If you leave out the parentheses, you'd get 9 divided by 2, and that wouldn't be 7.
Yeah, that's what I did. I didn't. I did the order of operations wrong.
Okay, so lots of videos to watch here, as well as the ones I will send you the links to with the textbook. The next thing we would get to is circles, but actually I want to take a break and talk about multiplication, because I had a question last Friday, about why our basic multiplication algorithm works, which is a good question. And I tried making a video about it, and it was just too ambitious to get from we don't know anything really to how to do a 5-digit times 5-digit problem with carrying all in one video. And I think there's plenty of websites and videos out there that you can search for doing the standard multiplication algorithm. Algorithm, again, is just the fancy word for recipe or process, just for learning about carrying and things like that. But I wanted to actually talk about it as far as why it works, because I'm not trusting other things will do that as well. Did I link it yet? I don't think I did, because that would have confused you. So I will go to the public folder and Math 20, and I have this all set up to be efficient. So let's talk about why multiplication works. And actually, I'm going to stop the recording and start a new one so that if people want to see just this part, they can. And if they want to see just the thing about geometry, they can. Sound good? So